Let's talk about scientific notation. When we're dealing with scientific notation, basically we're trying to take a number that might be either too large or too small, and we want to write it in a way that it has a certain number over here times 10 to a certain number over here. The number over here is usually an integer. We have it as an integer. Remember, integers are negative and positive numbers. So we want to take a number over here, multiply it by 10 to a certain power. Now, why do we need scientific notation? Well, as the name implies, scientific notation is mostly used, well, if you look at science, the things we study in science, you talk about planets, or you talk about distance to the sun, and you're looking at different scenarios there, right? So for example, 93 million miles is the distance to the sun, and instead of somebody writing that out as 93 and then 000,000, we can write that in scientific notation, and this is from planet Earth. So basically, imagine here that at the end of the number there's that decimal just sitting there at the end of any number, right? And if we don't give you that decimal point somewhere else, then you take this and you move it 1, 2, 3, 4, 5, 6, 7, right? So we move to the left 7 times. Whenever we move to the left, we actually technically will add up here. So we move to the left 7 times, so that's going to be a positive 7. And over here, we're going to put 9.3. So the answer for the distance to the sun in scientific notation would be 9.3 times 10 to the 7th. Now, we don't have to write the plus in front of that 7. If there was a negative involved, if we're dealing with a number where we had to have a negative, we would write it as negative, right? So think about large numbers. For large numbers, we're going to see, a number over here from 1.0 all the way to 9.9. Okay, this number here has to fit into that over there. It has to fit in between 1 and 10 essentially, but I say 9.999. Okay, so the number must fit in there that you get on this in this first box over here, and then in this integer box here, it depends on what the number of, how many times you had to move either to the left or how many times you had to move to the right. Let's look at another example with scientific notation. We looked at a situation where you had 93 million, right? What if we're dealing with something that is so small, right? Imagine if you're dealing with something the size of hair, like human hair, and somebody says, well, we have a range from 17 to 180 micrometers. Now, something to keep in mind is that we have to talk about micro, nano, pico in a different video. But what's interesting is recognize that if you were to write that out as a number using place value, and you wanted to write the micro, something that is in the micro range, which would be 10 to the negative 6th, then you would notice that we put that negative there when we're dealing with numbers, right? So this would be, if I had 1 times 10 to the negative 6th, that's 1 micrometer, right? And so we keep that in perspective in terms of there's times where we have negatives and there's times where we'll have positives, like in this case where we had 10 to the 7th power. So let's quickly recap how to deal with scientific notation. With scientific notation, we have a number times 10 to another number. We take the original number they give us, like 196, if they say write that in scientific notation. We move 1, 2. We move the decimal till we get to the point where this number can fit in here. And it has to be in between 1 and 10, which is technically, again, in this case, 1 and 9.999. We don't want, I personally have seen that we focus our efforts on putting it to 9.999, and we don't use 10 with scientific notation. So if we're using 1 to 9.99, okay, in this case, it's going to be 1.96. We move the decimal twice. So because we move the decimal to the left, we have to add to this over here. So that becomes a 2 over there. We can check our work by taking 1.96 and asking what is 1.96 times 100, because 10 squared is 100, and that becomes 196. So we see that it works. Let's try a situation where it's like 0.0045. If we have this situation, we have to move the decimal to the right. 1, 2, 3. So if we're going to the right, then we have to subtract from the power. So it'll be 4.5 times 10 to the negative 3. So notice that when you move to the right, you subtract from the power. When you move to the left, you add to the power. You have to move the decimal until it gets to a point where the number in the box here, the first number, is in between 1 and 9.999, and then you adjust the power of what the 10 will have in the power place. Thank you for your time, and keep working hard. Have a good day.